Welcome to Dr. Tarazi's Math Site. This video is one of a series covering the released Ohio State math questions between 2017 and 2023. Statistics and probability make 8% of the test questions. Standards 8.sp.3 through 4. Investigate patterns of association in bivariate data. Please pause and read the details of these two standards.
Hello and welcome. Here is what you need to know before we get to the examples.
Percentage rules.
These rules are very important to remember so you can use them correctly. The first rule is the percent over 100 is part over a whole. Percent over 100 is when you have some situations is an is over of, and we will see how this has been used. So you notice here you have three quantities, three variables, the is and the of and the percent. If two of them are given, you can find the third one. And remember that as an example, 0.42 means 42%, means 42 over 100, okay? So in a school of 680 students, that's the total number of students, okay? That's the whole. 306 students play basketball and 374 play soccer ball. What is the percentage of students who plays basketball? So P over percentage is the question. Part over whole, part is 306 over 680. So you get 0.045, and the question is percent, what percentage? Then it's 45%. Now here, what number is, so that's the unknown, is the unknown, 20% is given, of is given, so 20 over 100 equals n, that's the is, over 340. And then you do cross multiplication, 20 times 340 divided by 100, you get 68. So 68 is 20% of 340. 30 is what percent of 340? The is given, the of is given, percent is not given, is unknown. So P over 100 equals 30 is the is, of is 340, and again cross multiplication, you get P is equal to 8.82%. Okay. Another example here, 150 is the is given, 40% is given, the percentage is given of what number? That's the unknown. So 40 over 100 equals 150, that's the is, over n, of is the unknown, cross multiplication again, and you get 375. So 150 is 40% of 375.
Recommendation.
To make the most of these videos, I suggest pausing the video when you see this button, solving the problem, and then resuming the video to check your answer.
Example 1.
In this example, a runner tracks his distance in miles y, traveled over time in hours x. How he uses the equation shown as a model for his data. Y equals 8.2x. What does the 8.2 represent in this situation? The options given are the runner's average speed, which is really the answer. The total time the runner travels, no, that's an equation. The total distance the runner travels, no. The distance traveled by the runner at any time, no. So obviously this is a very simple equation. The answer will be the runner's average speed, the runner's average speed. The total time the runner travels, no. The total distance the runner travels has nothing to do with that. The distance traveled by the runners at any time, no.
Example 2.
This is an interesting example. A researcher surveys 60 employees, total is 60, at a company about their highest education level and the number of years of experience they have. The results are shown. 40 employees have a bachelor's degree, 20 employees have at least, etc. So the question here is complete the table to show the results of the survey. So now let's see what information are given to me. 40 employees have a bachelor's degree. Bachelor's degree total, I have 40, so I can fill up this here, 40. What is 20 employees have at least 5 years of experience and a bachelor's degree. At least 5 years of experience right there and a bachelor's degree, so that would be right here. That's given. The third piece of information, 15 employees have at least 5 years of experience and a master's degree. At least 5 years of experience and a master's degree right here. Now you have to fill up the rest of the table. Remember always, if you add these two, you get this. You add these two, you get this. You add these two, you get this. So now it doesn't matter in what order to do. So I put 20 here. Why? Because 40 plus 20 is 60. Then I put also 35 here because I added these two. Now, this is a 20, this is 40. Total is 40, that's 20. Then I have left with 20 here. This is 15, this is 20, this should be 5. Add 20 plus 5 is 25. Check. 35 plus 25 is 60. All matches or adds up correctly, so we're done.
Example 3.
The number of inches of rain Y after X minutes of rainfall during a storm can be modeled by the equation shown. How many inches of rain falls in 2 minutes? So what does that mean? In 1 minute, you put 1 here. 2 minutes, you put 2. 3 minutes, you put 3. So in 2 minutes, very easily, you put 2 here. You get 0.006 inches.
Example 4.
This is another interesting example. A company surveyed 200 shoppers, 200, okay, to find out what type of bottled water they prefer. The partial two-way table shown gives the results of the survey as relative frequencies, percentages, okay? What is the missing value in the table? So that's this one is missing. And then based on the results in the table, how many shoppers are men who prefers mineral waters? So first of all, let's find the missing information here. So either you do this plus this is equal to 0.58, or this plus this unknown is equal to 0.59, which means to find this, you can subtract this minus this, or this minus this. So 0.45, we found that. That 0.45 is done. The second question here, based on the results in the table, how many shoppers are men who prefers mineral water? Men who prefers mineral water is 0.13. So 0.13, it's 13%. 13% is part over whole. Part over whole. Whole is, go back to here, it's 200. So now you do cross multiplication, this times this divided by this, or you notice that from 100 to 200, I times it by 2. So 13 times 2 is 26.
Example 5.
This is another interesting example. A teacher surveys her students to find out whether they prefer riding a bike or playing soccer. The two-way table shows some of her data. Okay. Based on her data, the teacher concludes that if a girl is chosen at random from this sample, there is a 56% probability that she prefers playing soccer. What is the total number of students the teacher surveyed? Okay, I'm having trouble reading the small print here. Okay, so now let's see what we have here. We need to find the okay, this is a little bit kind of complicated, not complicated, but let's see, it needs some work. So let's see what we do here. First of all, let's see the information that we have. 56% of girls prefer playing soccer. Okay, that's given. That's here. Which means 44% of girls prefer riding bikes, right? What's 100% minus 56%? Now I'm going to write the question as follows. 22 girls, 22 is 44% of what number? 22 is 44%, because we know 44% of girls prefer what? Riding bikes, right here. And that comes up to be 22 girls. So 22 is 44% of what number? Of what number? Now again, you use the formula. 44 over 100 equals 22 over n. Cross multiplication, you get 50 girls. So you get 50 girls. Now, what is the total number of students the teacher surveyed? We need this. We need this. I know this is what? You add these two. You add these two. 51. 51 plus 50 is 101. And the answer is 101. So again, quickly, what we did is, based on this piece of information, 56% prefer playing soccer, which means 44% prefer riding bikes, which is giving to me right here. That's 22 girls, okay? So 22 is 44% of what number? We use the formula, and we get 50 girls. So 50 girls here, total number of girls. So 22, if you want, you can continue the filling up the table, but it's not needed. 51, I got it from here. Add these two together, you get 101.
Example 6.
This is a restaurant manager survey 80 people in 2 different age groups on whether they prefer turkey or chicken sandwiches, which two-way table shows an association between age and sandwich choice. We need an association between age and no association. We need no association, okay? So look at each one of this. Here, try to understand people age 30 and over, they like 30 turkey, 10 chicken. People under 30, it's the other way around. So there's some association here between the age and the sandwich choice. So that's not a good answer, because I need no association. Again, here, the same thing. People age 30 and over, 40 of them prefer turkey, and people under age 30, 40 of them. So again, there's a big association here between age and the choice of the sandwich. So that's also not a good answer. This one here, again, you see it's the same thing. People age 30 and over, 40 prefers chicken, and the people under age 30, 40 prefers turkey. So there's association here between the age and the sandwich choice. So that's not good. Now look at this here. There's no association here at all, because 20 of them here, they like turkey, 20 they like chicken. Here, 20 they like turkey, 20 they like chicken. There's no association here between the age and the choice of the sandwich.
Thank you for watching. If you would like to have a copy of the PowerPoint presentation, please leave your email address in the comments section, and we will be happy to email you a copy.
Thank you, and see you soon.
Thank you for watching. More videos to come. Please subscribe.